The minimum clearance for overhead conductors spanning a garage with a sloped roof is 10 feet according to the National Electrical Code, specifically sections 225.18b and 230.24 Bernier. These sections address the vertical clearance requirements for overhead service conductors and outside branch circuits. It's important to understand these requirements to ensure safety and compliance with electrical codes. The National Electrical Code, or NEC, is a set of standards that provides guidelines for safe electrical installations. It is updated every 3 years and is widely adopted in the United States. Article 225 covers outside branch circuits and feeders. An outside branch circuit is the portion of a branch circuit extending beyond the exterior walls of a building. A feeder is all circuit conductors between the service equipment, the source of a separately derived system or other power supply source, and the final branch circuit of a current device. Article 230 covers services. A service is the conductors and equipment for delivering electric power from the serving utility to the wiring system of the premises served. Section 225.18 specifically addresses clearance for overhead conductor, and 230.24 focuses on overhead service conductor clearances. The specific subsections B in 225.18 and Bernier in 230.24 detail the required clearances over residential property and other areas. In the case of a 240-volt system spanning a garage, the minimum vertical clearance is 10 feet above finished grade, sidewalks, or any platform or projection from which they might be reached. The 10-foot clearance is applicable to areas accessible to pedestrians only. This requirement is designed to prevent accidental contact with energized conductors and to ensure the safety of individuals and property. Several factors influence the required clearance, including the voltage of the conductors, the type of area spanned, and the presence of any obstructions. Higher voltages generally require greater clearances. The type of area spanned, such as a residential property, commercial area, or public road, also affects the required clearance. Obstructions, such as trees or buildings, may also necessitate increased clearances. To determine the correct clearance, firstly, identify the voltage between the ungrounded conductors. Secondly, determine the type of area the conductors are spanning. Thirdly, consult the relevant sections of the NEC, specifically 225.18 and 230.24. Fourthly, ensure that the actual clearance meets or exceeds the minimum requirements specified in the NEC. It is crucial to consider the sag of the conductors. Conductors sag due to their weight and temperature. The sag is the vertical distance between the highest point of the conductor support and the lowest point of the conductor between the supports. The maximum sag occurs when the conductor temperature is at its highest. The NEC requires that the minimum clearance be maintained under conditions of maximum sag. This means that the clearance must be sufficient to prevent accidental contact with the conductors even when they are sagging. Local codes and regulations may also impose additional requirements beyond those specified in the NEC. It is essential to consult with local authorities to ensure compliance with all applicable codes and regulations. Proper installation of overhead conductors is critical to maintaining adequate clearance. The supports for the conductors must be strong enough to withstand the weight of the conductors and the forces imposed by wind and ice. The conductors must be properly tensioned to minimize sag. Regular inspections of overhead conductors are essential to identify any potential problems, such as sagging conductors, damaged supports, or vegetation encroachment. Any problems should be promptly corrected to maintain adequate clearance and prevent electrical hazards. If vegetation grows too close to overhead conductors, it can create a fire hazard and can also provide a path for electricity to ground, which can be dangerous. It is important to keep trees and other vegetation trimmed away from overhead conductors. Damaged supports can also create a safety hazard. If a support is damaged, the conductor may sag or fall, which can create a risk of electric shock. Damaged support should be repaired or replaced as soon as possible. Sagging conductors can also create a safety hazard. If a conductor sags too low, it may come into contact with people or objects, which can cause electric shock. Sagging conductors should be retensioned or replaced as soon as possible. In summary, understanding and adhering to the NEC requirements for overhead conductor clearance is crucial for ensuring electrical safety. Always consult the latest edition of the NEC and local regulations to ensure compliance. Remember the 10-foot minimum clearance for 240-volt systems spanning a garage with a sloped roof, and always consider SAC, local codes, and proper installation practices. When calculating the clearances, one must also consider the ampacity of the conductors, as this influences the size of the conductor. Ampacity is the current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by its size, material, insulation type, and the ambient temperature. The NEC provides tables that list the ampacities of various conductors under different conditions. When selecting conductors for an overhead installation, it is important to choose conductors with sufficient ampacity to carry the expected load. The conductors must also be suitable for the environmental conditions such as temperature, moisture, and exposure to sunlight. The type of insulation used on the conductors is also important. The insulation must be suitable for the voltage and temperature of the installation. The NEC provides tables that list the types of insulation that are permitted for different applications. In addition to the ampacity and insulation requirements, there are also requirements for the mechanical strength of the conductors. The conductors must be strong enough to withstand the weight of the conductors and the forces imposed by wind and ice. The NEC provides tables that list the minimum mechanical strength requirements for various conductors. When installing overhead conductors, it is important to use proper hardware and techniques. The conductors must be properly supported and tensioned to prevent sagging. The conductors must also be protected from damage by abrasion and corrosion. The NEC provides detailed requirements for the installation of overhead conductors. It is important to follow these requirements to ensure a safe and reliable installation. Proper grounding of the electrical system is also essential for safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people and equipment from electric shock. The NEC provides detailed requirements for grounding electrical systems. It is important to follow these requirements to ensure a safe and reliable installation. Regular maintenance of the electrical system is also important for safety. The electrical system should be inspected regularly for any signs of damage or deterioration. Any problems should be corrected promptly to prevent electrical hazards. The NEC provides guidelines for the maintenance of electrical systems. It is important to follow these guidelines to ensure a safe and reliable installation. When working with electricity, it is important to take precautions to protect yourself from electric shock. Always turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Never work on electrical equipment when you are wet or standing in water. The NEC provides detailed requirements for working safely with electricity. It is important to follow these requirements to protect yourself from electric shock. Proper labeling of electrical equipment is also important for safety. Electrical equipment should be labeled to identify its voltage, amperage, and other important information. This information can help to prevent accidental contact with energized equipment. The NEC provides requirements for labeling electrical equipment. It is important to follow these requirements to ensure a safe and reliable installation. Surge protection is also important for protecting electrical equipment from damage caused by voltage surges. Voltage surges can be caused by lightning, power outages, or other events. Surge protection devices can help to protect electrical equipment from these surges. The NEC provides requirements for surge protection. It is important to follow these requirements to protect electrical equipment from damage. Remember to always consult with a qualified electrician for any electrical work. Electrical work can be dangerous, and it is important to have the work done by someone who is properly trained and experienced. A qualified electrician will be able to ensure that the electrical system is installed and maintained safely and reliably. They will also be familiar with the NEC and local codes and regulations. In conclusion, ensuring the correct overhead conductor clearance, especially over structures like garages, is a multifaceted task that involves understanding and applying various aspects of the NEC, local regulations, and best practices for electrical safety. By paying close attention to voltage, ampacity, conductor type, installation techniques, and ongoing maintenance, you can create a safe and reliable electrical system that protects people and property from harm. Always prioritize safety and consult with qualified professionals when dealing with electrical installations. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. Electrical codes and regulations can be complex and vary depending on location, so it's crucial to stay informed and seek expert guidance when necessary.